So good afternoon, everyone. My name is Susan. I'm one of BBD's graduate developers. Today I'm going to tell you a little bit more about my honors project I did last year. So please excuse me if I sound a little bit rusty, because I am. So when I had to choose a topic last year, I knew I wanted to pick something that is close to my heart. Something that you do not know about me yet is that I grew up in Webstad, which is a very small town in the Free State, approximately 150 kilometers from Bloemfontein. Before you ask, I'm not so Afrikaans that I say Webstad instead of Hopetown. It's actually two different places. So Webstad is mainly a farming community, and I have three uncles. All of them are farmers, and they always need some kind of solution on the farm somewhere. So when I had to choose something, I decided I'm going to combine my love for agriculture and technology, which is where this idea started off. Oh, sorry. Oh, goodness. Next slide, sorry. So, the system I designed is a full-fledged system, not only to monitor and manage devices inside a greenhouse, but automating the irrigation as well. Although the system was developed for a farmer, it can also be used in gardens as well. So to achieve my goal, I took Raspberry Pis fitted with sensors, a MongoDB database, and I wrote a Kiwi application. So most of you probably know what a Raspberry Pi is. For those that you don't know, it's a low-cost, credit-size, single-board computer, and its GPIO I/O pins can be easily controlled with a Python script, and then you can add sensors to them, which is relatively inexpensive and accurate. So also use the MongoDB database, which is a document-based database. And the main reasons for using it was because they offered like a sandbox free tier subscription. Okay. I'm just going to share my screen again. Sorry for that. So I used, for the user application, I used the Python language and the Kiwi library. Later on, I will show you a couple of screenshots. In the end, I actually struggled to install it on a mobile device, but I did run it successfully on both Linux and Windows. Okay. So a little bit more about the application. It's basically just a tool to manage the greenhouses and the devices installed, and it actually helps the user.
Yes. So you're listening to the talk about multitasking.
And group the devices into experience.
Smoke. Do you think about this?
Lucky, will you mute?
Oh, pardon.
It's fine. So a little bit more about the application. It's basically just a tool to manage the greenhouses and the devices installed, and it helps the user to actually group their devices and to experience near real-time feedback. So the first, let me just, how do I? Okay, so this is basically the login screen, and this is not linked to a device, but rather to the user's email address. So it means that you can sign in on any device using your email address, and there's also admin functionality, but I'll get to that later. And this is basically the greenhouse home screen. Note that the greenhouse is not necessarily the Raspberry Pi, it's rather a collection of devices in your greenhouse, so it's just a way to group them. On the next screen, you have your actual Raspberry Pi device, and you will see that there's just a little bit of information. And then there is a dashboard for each device with all the sensors you installed, information about that. And there's some of, I'm not going to go into the icons now, but you can actually manually change, or whether you want to manual irrigate or actually automate the irrigation, and then you can set the threshold when it should start the irrigation or not. And then more than just the first dashboard, you can there create alerts a schedule, and also view the history for each of the sensors installed. Okay, so now for the more interesting bits. I really like working with Raspberry Pis, so and I think it can be really powerful. So the main functionality of the greenhouse devices, which is the actual Pis, is to collect data and to control. So the sensors I installed was a flow meter, a temperature probe, which I use for the soil temperature, a DHT22 temperature and humidity sensor, which is for the air temperature and humidity, and a soil moisture sensor. I also connected up a 12-volt solenoid valve to open and close the water, a relay to trigger that, and an analog to digital converter for the soil moisture sensor. Okay. This is just the database design. So the device, the Raspberry Pi, will mostly communicate with the device, the timestamp, and schedule state and schedule item collections. And the other tables is actually more for the handling of it, so for the user application. So this is just a sample of how the data the Raspberry Pi sends looks. Yes. Okay. So this is just, I decided one day I want to test what happens and how the data actually looks. So on the left-hand side, you'll see the test day 1. So for this scenario, it was in my garden for about 4 hours. So I set the threshold value to 60. So it means that when the soil moisture reach 60%, it turns off, and below 60, it turns on. So on the left-hand bottom, you can see that it actually maintained it quite well with an average of the 60%. And on day 2, I did something different. Instead of just putting a single value, I put a range of 55 to 65, meaning that the irrigation would turn on if the value is less than 55, but it will only stop at 65. And it was in my garden for 10 hours, and which is how it resulted. This was in the night, so which is why the temperature dropped. Okay, so just a couple of limitations and possibilities I see for this. The limitations is definitely the internet connection, because a lot of farmers doesn't have a strong internet connection, and both the user application and the Raspberry Pi needs to be connected to the internet. And also the power supply, because there needs to be a power supply near the Raspberry Pi, but that can easily be resolved with a solar panel. And then the possibilities is definitely to not just control the water, but also climate control, opening windows, putting on fans, something like that. And also introducing some decision making based on the environment or the planted crop. And outside of greenhouse functionality, the system basically just takes existing operation and adds the ability to process remotely or automating it actually. So with a couple of changes, the same technologies can be used in various operations like dairy management, fuel management, or water management. And that was me for the day. So if you have any questions, you can ask them.